So what we are looking at today, we are looking at the rhombus and we are looking at the square. So if you notice in the title here, this says rhombi. That is just the plural of rhombus. So what a rhombus is it is a special type of parallelogram. So therefore, if you guys consider the properties of a parallelogram, these all will still apply to the rhombus. So as we build our hierarchy, which we'll talk about more later, you have the parallelogram at the top, and it splits two different directions. One direction goes to the rectangle, and then the other direction goes to the rhombus. Okay, so first off, all of the properties we've talked about for a rectangle do not apply to rhombus. However, all of the properties we've talked about for a parallelogram does apply to the rhombus. So as you look at these first five, these are things we should be able to get by now. So I'm going to again pause the video, let you fill these in. So hopefully we have that the opposite sides of a parallelogram are parallel. Again, you want to talk yourself through, okay, besides the sides being parallel, what else is true about your sides? Well, the sides are also congruent. And then you ask yourself, okay, what else is congruent? Those are your opposite angles. And then you ask yourself, okay, what else about the angles? Well, the consecutive angles, those are the ones that are supplementary, or they add up to be 180. And then we have that kind of random one there that's talking about your diagonals. And again, your diagonals bisect each other. Okay, so again, they intersect at their midpoints. So like we've talked about before, those five properties still apply to the rhombus. The only new piece to this is a rhombus is a parallelogram with four congruent sides. Now, here's the thing. When you guys go to look at this next piece, the summary of the investigation, we did not do the constructions of the rhombus. Okay, so one of the things that we notice about the angle bisectors and the perpendicular bisectors of the diagonal. Here's the thing. What I want you to do is I'm going to ask you to just totally ignore this. We're going to draw a picture to kind of help with this as we look at property 9. So the property 9 is that the diagonals bisect the angles. Okay, so let me go ahead and get a figure here that is as close to a rhombus as I can get just by sketching it. So when we look at this, okay, again, your rhombus has four congruent sides. So that's your property number 8, that's your definition. If we look at your diagonals cut those angles exactly in half. So this angle will be the same as this angle. We talk about the idea that it's a parallelogram, so the angles opposite will also be exactly the same. Then we also have the angles at the other corner that are congruent. And again, because it's a parallelogram, the opposite corners will also be the same. So if you notice right now, based on angle side to angle, we actually have four congruent triangles around the outside, or around the inside, excuse me. So not only do we have that the diagonals bisect the angles, but the diagonals are also perpendicular. So as you look in the middle of your figure, you actually have a 90-degree angle here. So not only are they four congruent triangles, they're actually four congruent right triangles. Okay? So the nice thing is, the more properties you have, the more properties you understand, the easier it is to come up with missing angle measures. So as soon as we see that it is a rhombus, we know that the angles around the middle, both all 9, 10, 11, and 12, all of those are 90-degree angles. So we've got 90 degrees, 90 degrees, 90 degrees, and again, 90 degrees. Okay, they also give you that angle number 1 is 25 degrees. Well, since we know it's an angle bisector at that angle B, this is also going to be the same, as are the two angles over here in this corner, because they kind of fold over, they have that symmetry component there. So this is 25, and this is 25. So right now, what we have is we have angles 2, 5, and 6. So 2, 5, and 6 are all 25 degrees. Now, if we take and use the idea that we have a right triangle here, we have 2 of the 3 angles given to us. So to figure out angle 4, we're going to add 90 and 25. and that gets us 115, and then do 180 minus 115, which gets us 65 in this corner. And again, if that angle is bisected, that means angle 3 is 65, and because we have opposite congruent angles, that's 65, that's 65. So we have 3, 4, 8, and 7. So 3, 4, 8, and 7, all of those are 65 degrees. Now, the only other component we have to pay attention to is the other ones that they're asking you for. So ABC is the big angle at B, which tells us that that's 50 degrees. Moving down that column, BCD is the big angle at C, so 65 plus 65 is 130. Now, that makes sense because, again, if this is 50 and this is 130, because it's a parallelogram, those two are supposed to equal 180, which they do. If we look on to CDA, again, we're going to combine that 25 and 25, or we can recognize B and D are opposite congruent angles. And then we also have DAB is going to be the same as the BCD, so these are going to be the same, and those are going to be the same. Okay, so again, the more properties we have, the easier it is to find our missing measures. Now, if we look at the next example, if AB equals 48 centimeters, BC equals 4y, CD equals 12x, and AD equals 8z. Here's the thing. We don't even really need to see the picture, because if we know that it's a rhombus, well, we know all of those sides are going to be equal. So to start, we would set 48 equal to 4y. We would do then 48 equals 12x. And then last but not least, 48 equals 8z, and we would divide to get all of those values. So our x, 48 divided by 12 is 4. 48 divided by 4 gets us 12 for the y, and 48 divided by 8 gets us 6 for the z. So again, as long as we know it's a rhombus, we know all of those sides are going to be equal. All right, so I'm going to let you pause the video, work through example number 3. Let's see what we come up with for our missing measures. Okay, so as you guys look at this, let's talk about the sides first. So ZY is 34. If it's a rhombus, that means all of these sides around the outside are going to be 34 also. If we know that YW is 38, because it's a parallelogram, we know that this diagonal has been bisected, meaning those two pieces are the same. So we can say that this is 19 and this is 19. Okay, so let's pause there and figure out what we have so far and what else we maybe need. So WZ we have labeled as 34. VY we have labeled as 19. ZB we don't know. Okay, so I'm going to pause right there. Let's take a look at this. So if I outline this right triangle, what I have is a right angle here, 19 here, 34 for your hypotenuse. And again, we're going to solve this by using your Pythagorean theorem. So x squared plus 19 squared gets us 34 squared. We do each of those components. So 19 squared is going to give us 361. 34 squared is going to give us 1156. And we're going to subtract to figure out what x squared is equal to. So x squared at this step equals 795. And then if we do the square root of that, we get 28.2 for this value. Now, if that's 28.2, so is this other component of your diagonal. So then we would just double that, or we would add it together to get 56.4. Okay? So again, we have that Pythagorean theorem in play because that right angle in the middle. We haven't seen that before as far as the right angle in the middle with our other figures. Now, I'm going to erase this because now we're going to transfer into our angles and try to figure out our missing pieces based on just this information. So ZXY is 34. So our other angle is 34. Same thing on this corner, 34 and 34. Again, we have a right angle here. So we can use any of our right triangles here and do 180 minus the center angle of 90 minus 34. That gets us 56, and that's all of these angles at these corners. Okay, so let's go ahead and figure out what it is they're asking for. So to begin with, WXZ. WXZ is just that corner there, that part of the corner there at X. It's not the whole thing. So therefore, that's 34. WVZ is the angle here in the middle. All of those angles in the middle are 90. Z, Y, W. So Z, Y, W. That's the angle 56 there in the corner. And last but not least, X, Y, W. So X, Y, W is going to be 56 also. All right, now here's the thing. Okay, today's lesson is all about the rhombus and the square. The thing with the square is a special type of parallelogram. It's also a special type of rhombus. It's also a special type of rectangle. So as you go back to this hierarchy, basically what that means is a parallelogram splits to be a rectangle and a rhombus, and a square is just the rectangle and rhombus into one figure. So let's talk about this. You guys can write this down as we go. You do have this written down. We're going to have this in your hierarchy, so hopefully you have another location for these properties. But here's the deal. We're going to talk about it. Because it's a parallelogram, you're going to have 5 properties from there. And those are the 5 properties we've talked about before. So you got 5 total from it. One being that the opposite sides are parallel. Second one, opposite sides are congruent. Then you ask, what else is congruent? The opposite angles are congruent. What else about the angles? Consecutive angles are supplementary. And then you have the diagonals bisect each other. Okay? Then we went on to talk about the rectangle. And with the rectangle, you also had the idea that your diagonals were congruent. Okay? Not only did you have the diagonals were congruent, but you also had that the angles at the corners are 90-degree angles. So you had 2 properties from that. And then you have, from the rhombus that we just talked about a second ago, you've got 3 more properties. One being that the sides are all congruent. One, that you have the diagonals bisecting at the angles. So these are going to be congruent. Same thing here and here and here and here. And then you also have the perpendicular diagonals in the middle. So you've got your 3 properties from there. So you will have a total, for a square, you will have a total of 10 properties that trickle down to that square. So with that, something to keep in mind as far as specifics for the square, these are always 90-degree angles. If these are 90 around the outside and this is bisected, all of these are always 45, no matter what. So anytime you have a square, these are the same angles no matter what. The length may vary, but your angles for a square will always be in that pattern, okay? So hopefully that all made sense. I know it's a lot. Again, keep that hierarchy handy so that way you guys can refer back to it. And as always, if you guys have questions, just let me know.